Welcome back. In this video, we're going to take a look at FindElement. So we're going to see how we can get from the starting point element to the element we want to actually interact with. We're also going to take a look at conditions and tree scopes. So let's jump into VS Code. And here I have a small script that finds the calculator window, activates it, waits for it to be active, and gets the element for the calculator window. So if I run it, the calculator window is highlighted. So what if we wanted to get to, for example, the number 5 button to click it? So let's inspect the calculator window with the inspector tool. And we see that button number 5 has the name 5. It's the type button and has an automation ID of num5 button. So we could use either the automation ID, or in this case also the name is unique, so we can use either to find it. And we can do that by starting from the calculator element and then using FindElement. Now FindElement takes as the first argument a condition. So I can show it right here. So condition, or the condition to filter with. In this case, we want an element that has the name of 5. And in this case, what this function is going to do is it's going to try to find an element where the name property is equal to 5. So here, if I assign this object to a variable and use its name property, then we see that we get 5. And FindElement tries to find an element where the element's name property is exactly equal to the name property of the object. So here it's gonna find the number 5 button. This is by default case sensitive and it needs an exact match. For example, if I put the space at the end, then it doesn't find anything. If we wanted to find an element that is an inexact match, then we have to change the match mode. In this case, we can use, for example, substring. Match mode of substring means that only part of the name must match. So we can, for example, delete first character and it finds the number 5 button still. We can also use match mode starts with, in which case the element's name must start with this. So in this case, since we tried to start with IFE, no such element is found. But if we start with FIV, then it finds 5. Also, there's the regex match mode where it matches using regex, but we're not going to talk about that in this video. We can also change the case sensitivity or case sense. So we can set this to either true, false, or we can put it to on or off. So let's try with case sense off and use lowercase f or lowercase 5. And we can see that it found the element. We can also use a combination of these if we wanted to. And for example, we can use substring here and it still finds it. Since this object might get quite long, we can also use a short version of this, which is CS, short for case sense, or MM, short for match mode. And it acts the same. So this is how we can find one condition. What if we wanted to be more specific and we wanted it to be exactly a button type element? So then we can use also the type property and set it to button. So in this case, we are saying that the element must be named 5 exactly, and it must have the type of button. So if we inspect the calculator again, then we see that here the type is actually a number. So this is 50,000. This is the numeric version for the button type. So we can also use 50,000 and it still works, but it's harder to understand later on. So I recommend using the word instead. Okay, so now we saw how we can use an AND condition. We can also specify what the type or some property mustn't be. For that, we can use the not property, which needs to have a condition of its own. So for example, if we said that the type mustn't be a button, then we don't find any element. If I change this to menu item, then the button is found because this is not of type menu item. We can also search for either one element or another element or another condition with an OR condition. And to create an OR condition, we need to use an array of conditions. So here we can create an OR condition with only one condition. So name must be 5, and this works. Or we can add another one and say that we either want to find an element with name 5 or an element with name 6. So here we still find the 5 button because 5 comes before 6 and the search doesn't get to 6. But if we change this name slightly, then we can see that the 6 button was found instead. Okay, so this is how we can combine conditions with AND, OR, and how to create NOT conditions. So the next argument is scope, or the tree scope, which needs to be one of these special tree scope values of element, children, descendants, or subtree. And let's try to see what the tree scope means. So if we take a look at the UIA tree for the calculator, then the element at the top is the element itself, or the starting element. This is tree scope element. Next we have tree scope children, which refers to only the direct children of this element here. So if we start the search from here, then the children refers to only these 3 elements. So if we limited our search to children, then it would only look at those 3 elements, going no further. Descendants refers to the children and the children's children. So if we use tree scope descendants, which is the default scope, then it starts from this element right here, then it goes on here, here. Since this doesn't have any more children elements, then it goes back and looks at the next one, and so on until it gets to an element that matches the condition exactly, and in our case it would be right here. Here we can see that our element is almost the end, and this is good to remember that the search works this way. So it looks at all these elements before getting to this. So later on we're gonna look at how we can reverse the search direction, so it would go instead like this, and it finds the button much faster. So this was element, these were children, and including the children's children is called descendants. If we also wanted to add the starting element as well to the search, then this is called, if we combine it with descendants, then it's called subtree. So all these elements are called subtree. And if we wanted to only look at the element and its direct children, then that would be called family. So these are the scopes, and we can access the values of those by using UIA.freescope dot and whatever we want to set as the scope. So we can, for example, use treescope element, which would only look at the calculator window itself because it's the starting element and it doesn't find anything. We could also use children, in which case it looks only at the children, which doesn't include the 5 button and doesn't find anything. The default value for the tree scope is the sentence, and in this case it does find the element. And we could use subtree, in which case it also finds it. But it also looks at the starting element, and we know that this can't be the 5 button because it's the window element itself. So usually it's better to use the sentence. And the bigger the search scope is, the slower the search usually is. So in the case of calculator, we can see that there are a bunch of elements that have to be looked at before getting to this. So it's always good to try to limit the search scope as much as possible. For example, in this case, we could first look for a window type element, then perhaps try to find this group element right here, then get to the number pad and then look in the number pad instead. So that would cut out a lot of searching. Okay, the next argument is index. Index tries to find an element matching the condition, but the nth element. So if we had a condition to look for either an element named 5 or an element named 6, so let's quickly create this. Name 6. So if we look for the first element, then it finds the 5 because 5 comes before 6 in the tree. However, if we look for the second element, then we find 6 because FindElement first finds number 5 because it matches this condition. But since it's only the first match, then it continues on to find the second match, in which case it finds 6 and returns 6. If we try to find the third element with this, then we find no matching element. For the index, we can also specify a negative number, which means the search starts from the back instead of the beginning. So in this case, it found number 6 because the search started from the last element, then started going in this direction until it gets to the first matching element, which is 6. Because if index were 1, then the search would start from here and go on like this until it finds number 5. So this is how we can also change the direction of the search. Order is another special value of tree traversal options. So here the default value is pre-order, which means the search starts from the top of the tree. So it starts from here and continues on until it gets to the deepest one, and then it jumps to the next one. However, if we wanted to start from the deepest element and then go back up, again deepest, then up, then again deepest, and so on, in which case we could use post order. So here, this doesn't change the matching element, but it sometimes might speed up the search if you know that you are looking at the deepest element instead of the topmost element. And the last one is starting element. So we can specify another element here to start the search from. So if we had the 5 button already, so let's find it. And we started the search from the 5 element. Then it finds the number 6 because our tree scope doesn't include the element itself. If we added the tree scope element, then it finds 5 instead, because this makes it look for the starting element as well. So if we wanted, we can also use the same arguments inside the condition. So for example, I can just type index of 1 and it finds the first element matching the name 6. Or I can add the starting element and 5 and it finds number 6. This is named named parameters, so it might be a little bit easier to read what you are actually using to find the element. This is it for FindElement, and in the next video we're going to take a look at the elements themselves. See you in the next one.